Similarly to the Cramer's rule for systems of two linear equations with two variables, we can state the Cramer's rule for larger systems. We'll discuss only systems of three linear equations with three variables. So suppose we have such a system written in the standard form. That is, each equation contains only terms with the variables written in the same order. Variables here are x, y, and z. The right-hand side contains only numbers. We define four determinants, four 3 by 3 determinants. Determinant D contains the coefficients of the variables. In the first column, we list coefficients of the variable x in the order of the equations. So the first in that column is the A, and then D, and then G. The second column will contain the coefficients of the y variable, and therefore those coefficients are numbers b, e, and h. And in the third column, we list the coefficients of the variable z. Then we'll form the determinant dx by substituting in the determinant d the column of x with the column of numbers from the right-hand side. And the column 2 and 3 will remain the same as in the main determinant. To form determinant dy, we'll replace column of the coefficients of y with the numbers on the right-hand side, s, t, and u. And to form determinant dz, we'll replace the coefficients of the variable z in the main determinant by the column of numbers from the right-hand side of the system. Now, once we have those four determinants, we can state the following facts. If main determinant D is not zero, then the system has exactly one solution, and that solution can be expressed in the form dx over d, dy over d, and dz over d. So dx over d is the value of x, dy over d is the value of y, and dz over d is the value of z that solves the system of equations. Now, if determinant is 0 and all three determinants are also 0, then the system has infinitely many solutions. We know that in this case the solutions could be a line or a plane, and to figure out which is that solution, we'll have to solve the system using elimination or substitution method. Now, if main determinant D is 0 and one of the determinants dx, dy, or dz are not 0, then the theorem states that the system has no solutions. This theorem gives us formulas for the solutions of 3 by 3 system if the main determinant is not 0. So by using this formula, we can eliminate sometimes lengthy process of solving such systems using substitution or elimination method.